In this lesson, we're going to do an example of your 6 trig functions. So we're looking for sine, cosine, tangent, cosecant, secant, and cotangent. There's 2 different ways to go about doing this. I'll do one example with more of a visual approach, and then the other example more of kind of a definition approach. So if I'm going to be trying to find the 6 trig values, I look at this as I'm just going to plot this point, and just kind of a rough idea. Then I'm going to go out 8, up 15, and here is my point. And then I'm going to connect this, and this would be part of a circle. Is kind of the idea that everything's kind of cyclical. So there's some things that we can do on the next one with kind of a definition. But I look at this more kind of a geometry style, where I'm going to plot my point, and I'm going to make a right triangle out of this. And if I want to figure out what sine is, cosine, and theta, I am going to, I need sine of theta, I need cosine of theta, and I need tangent of theta. I also will do the reciprocals, but I'm going to get sine, cosine, and tangent first. So from here, I have myself a right triangle, and the opposite is the height of that thing is 15, the horizontal is 8, and I need, basically I'm going to look to do SOHCAHTOA. So sine is going to be opposite over hypotenuse, so I need SOHCAHTOA. I need opposite and hypotenuse. So I'm missing the hypotenuse, so I can do Pythagorean theorem to figure out what my hypotenuse is. So if I do Pythagorean theorem, I'll do leg squared plus leg squared equals hypotenuse squared. So leg squared plus leg squared equals hypotenuse squared. Call it the radius. So 8 squared is 64. 15 squared, 225. And then if I add them together, I get 289. And then I'll square root both sides. So my radius is 17. So label my picture, and I have everything I need. So sine is going to be opposite over hypotenuse, 15/17. Cosine is going to be adjacent over hypotenuse, 8/17. Tangent is going to be opposite over adjacent, 15/8. And then cosecant is just the reciprocal. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. All right, so that's kind of a geometry approach, and it will work for you every time. But let me do a different one, and this is a more of a, let's look at the definition of things and take that approach. Could we plot the point? Could we draw a triangle? Absolutely. But you could also, you just have to remember that sine is y over r, cosine is x over r, and tangent is y over x. So you have to know the definitions of them. So here is your x and here's your y. What you're missing is the radius. So remember that the equation of a circle is, this is again a point on the circle, x squared plus y squared equals your radius squared. So you could just take -4 squared plus 3 squared equals your radius squared. So that's 16 plus 9 equals r squared. 25 equals your r squared. Square root your radius equals 5. So you have literally everything that you need. So sine of theta is going to be your y value, 3 over your radius. Your radius is always going to be positive. We don't need a positive and a negative out of that. So keep your radius positive. Cosine is going to be x over radius. And then tangent is going to be y over x. So -3/4. And then your reciprocals. So the reciprocal for sine is cosecant Reciprocal for cosine is secant. Reciprocal for tangent is cotangent. So if you have these, you have these. So 5/3, -5/4, and -4/3. And that is a little bit of a different approach. Could we have plotted the points? Could we have drawn the triangle? Yeah. The one thing that you want to be careful with is you are going left and then up. So when you draw your triangle, just be careful that, I know you're making a triangle, but you still are putting it onto an X and a Y axis, so there are positives and negatives. So to get these negatives to flow through, you're going left 4, so make that side a negative, make your height positive because we went up, and then your hypotenuse, and some of you will recognize right away that it's a 3, 4, 5, or Pythagorean theorem would have looked just like that. And from here, if you keep a negative appropriately because you went left, your negative will flow through perfectly. So, all right, so that's our first set of finding trig values from a point.